In Washington, D.C., more than 330 million gallons of wastewater flows into the Blue Plains Advanced Wastewater Treatment Plant each day. Heavy rainstorms cause over 3 billion gallons of this wastewater to spill into D.C. waterways each year. In D.C., wastewater from buildings and homes flow directly into the same pipes as stormwater. This is known as a combined sewer system. With the growth of D.C. over the years, the amount of stormwater and wastewater flowing through these pipes has increased significantly. As a result of urban sprawl, the area of available natural coverage has decreased and been replaced with impervious surfaces that disrupt the water cycle of an area. As seen in this picture, impervious surfaces only allow 15% of rainfall to be absorbed, where natural ground cover allows 50% to be absorbed. As a result, excess stormwater runoff gets directed into storm drains, which are combined with wastewater and taken to Blue Plains Advanced Wastewater Treatment Plant. However, during heavy storms, DC's wastewater system cannot take the volume of both stormwater and wastewater. When the pipes cannot sufficiently manage the volume of wastewater flow, it is released into the natural river system, leading to what is known as a combined sewer overflow. This means that wastewater and sewage that would normally be treated at the Blue Plains treatment plant is now freely flowing in DC waterways.
Although it seems that the best solution for CSO would be replacing the combined sewer system with a separated system, there's simply not enough funding for such an extensive project. As a result, the most efficient way to address this problem is through the use of water containment systems that serve to reduce the amount of water in the system and prevent overflows. In 2001, DC Water implemented a long-term control plan that they officially titled the Clean Rivers Project in 2010. The main focus of this and other smaller plans is to prevent sewage overflow into DC's rivers and streams through the use of design structures that can capture and clean water during heavy rainfalls and prevent the stormwater from entering the rivers. Included in the project is the Combined Sewer Overflow Abatement Program, which aims to maximize inline storage and to lessen the amount of overflow into local waterways through the use of inflatable dams, dynamically controlled weirs, flow regulating devices, a swirl treatment facility, and sewer operations. Green infrastructure such as green roofs, porous pavement, and rain gardens help to treat water naturally by capturing, slowing, and cleaning stormwater before it enters the combined sewer system.
In an average rainfall year, DC sewers overflow into the Anacostia River 82 times, equaling an estimated 3.2 billion gallons of untreated wastewater that flows into the Anacostia, Potomac, and Rock Creek waterways. Contaminated waterways have the devastating potential to harm health of the population and environment surrounding them. The most immediate harm that society faces from CSO are the effects of microbial parasites. These are pathogens that live in sewage water and can be released into waterways and make their way back into drinking supplies. When pollutants from ineffective wastewater management systems reach natural bodies of water, the environment suffers major consequences. When pollutants enter the environment through bodies of water, the excess nutrients promote algal blooms. The algae depletes the dissolved oxygen in the bodies of water and decreases the amount of sunlight that penetrates through the water's surface, leading to a reduction in aquatic wildlife and plant life that damages the ecosystem and its food chain.
The Clean Rivers project aims for completion in 2025 and will cost an estimated $2.6 billion. However, portions of the Anacostia River will see positive effects by 2018. Clearly, the overflow of sewage into DC rivers and lakes is a serious problem with numerous health and sanitation concerns both for the wildlife and humans. Although replacing the combined sewer system currently in place would resolve the problem, the cost and scope of such a project is currently not viable. As a result, DC Water has implemented many projects, most notably the Clean Rivers Project, which is working to reduce the rate and volume of water that enters the combined sewer systems with methods such as inflatable dams and green infrastructure. If utilized correctly, these methods will effectively prevent an overflow of sewage by reducing the rate at which water enters the system. Although this problem is far from resolved, the efforts of DC Water are quickly helping to reduce the problem of sewage overflow in DC.